guys, today we're doing titratable acidity. Um, so what you'll need for this is beakers, a wine sample, Erlenmeyer flask if you prefer, same than a beaker, stir ball and stir plate, of course DI water. We'll be using 0.067 NaOH to titrate, and then phenolphthalein as a color indicator. You also need a pH meter. The first thing you want to do is to calibrate the pH meter. We just did this. If you want to know how to do that, go ahead and check our pH meter calibration video. Tell you everything you need to know. Okay. So first thing we want to do is fill up the burette with the 0.067 NaOH. Fill it to the top. Did. And then you want to purge the burette so that as to make sure there's no air in here. So just give it a quick purge. No air bubble. This one seems to be retaining. Here we go. We'll get just a little more 0.067 in there. Okay. Next thing you want to do is note your starting point on the burette, which in our case is 0.9 mils. Take note of this. And then we want to prep our sample, which take a clean beaker, get a stir bar in there. We want to add 100 mils of DI water. This is mostly so that it's easier to have the probe of the pH meter fully submerged, so you don't need to be ultra precise about this. And then you want to take a couple drops of phenolphthalein, 2 to 3 drops. For the wine sample, you do want to be really precise, so we're using a 5 ml pipette, which will allow us to measure this. Add it to the solution. To set up the pH meter too. Store solution off. Rinse with DI water. We'll wait until we get a good starting measurement on the pH meter. we'll start to slowly add NaOH until the pH is 8.2. Little by little, and after I add a little bit, I'm going to let the pH meter catch up, get a precise measurement. You can see as we add the NaOH to the solution, it reacts with the phenolphthalein and creates that pink color. Another indication of when you get to 8.2 pH, the pink color will stick. And you want a really clear, pale pink color. If you go to purple, you went too far. You can see for now the color just sticks for about a second. It's a little better. This is the color we're after. As you can see, we were at 5 pH and it's jumping really quickly. It tends to go slow at first, and then when you get close, the pH will jump pretty quickly. So we'll let the pH meter catch up and see where we're at. Again, the goal is to get to 8.2 pH. This pale pink color makes me think that we're really close. Or here's 8.2. Hopefully we didn't go too far over. So the goal is to get as close as you can to 8.2. Note that at this point it's a matter of a couple drops difference of NaOH, so you will never land right on 8.2. But if you get to that color, you did it right. So let's just say that this is acceptable. And then once you're done titrating it, you'll take, let's see how much NaOH we used, which right now we are at 7.8, 7.9 maybe, which means we used 7 mils total of solution because our starting point was 0.9 mils. So what we'll do, once you have how much milliliters of base you used, you'll plug it in the equation right here and run this math. So whatever you use times 0.067 times 0.075 times 1,000 divided by 5. And if you did use 0.067 NaOH, your result, your titratable acidity in grams per liter, will be however many mils of base you used. So in our case, we used 7 mils of base, which means 5 grams per liter will be 7 grams per liter of TA. Once you have your measurement, you can take the probe out, rinse it. Back in the storage solution. That's it. We're good to go.